자, 수업 렉처 시작할 테니까 렉처 파일 열고 오케이. 지금 화장실 간 사람은 또 글쎄 뭐지? 응? 오케이. 오케이, open the slide. Okay, today's lecture, lightings, camera, and geometric modeling. That's the topic for today, okay? By using 3D Max design. Here are what to do today. We're gonna have 3D graphics and 3D Max design-based lighting, camera, and some mentally-based renderings, and some basic fundamental of geometric modeling, and the very primitive but very important geometric modeling technique, editable poly, okay? So even if you already experienced that kind of lab exercises and how to make those things and how to make that kind of visual effects, anyway, this lecture is kind of fundamental for your information, okay? So we have series of lab exercises, three camera views making camera, and some render environment using lightings, and some modeling issues for your geometric modeling technique, okay? So the first topic is light, okay? In 3D Studio Max, as well as some other 3D graphics-based tools, obviously there is light, but as a default light, when you start over 3D Max or SketchUp, Rhino, whatever, there is default light, but the quality of that default light is really low. That is why we need to install Mental Ray Sky. But last week we experienced how to use lighting system. The name of light is photometric light, okay? Photometric light is simply ray traced, very sophisticated and well-designed high-quality lighting system, okay? Photometric light, but only for Mental Ray, default renderer. If you are using V-Ray, you have to install V-Ray light, okay? Not photometric light or just standard light. Actually, standard light is okay in both V-Ray and Mental Ray, but photometric light is Mental Ray specific. That's why you are using photometric light today. Very simple, but let me list up what you have to know about the light. Of course, on and off, and you can turn off against a specific object, okay? There is 3 cups, but if you don't want one cup doesn't get some light, you can turn off only for that second cup, something like that, okay? Of course, turn on and off shadows. You can turn on and off shadows by the object. And the most important thing, distribution type, photometric web, spotlight, and something else. And of course, color of that light or some filter, and speechless. We don't need to say, or we don't need to put more emphasis on the importance of brightness. When you are learning V-Ray light, we used intensity. Intensity means 2 times brighter than before, or 100 times brighter than before. But in 3D Max, take a look at intensity. Lumen, candela, lux. There are some standards in terms of lighting brightness. In other words, if you have 1,500 candela, and if you realize it's really dark, you can put more zero. I mean, 100 million, okay? 1 and 6, 7 zeros. Amazingly large number you can put on that intensity because its unit is candela, okay? So when you are using V-Ray, 1,500 is really exaggerated and too bright, but in 3D Max, that's not that bright, okay? You have to know that. Another one, if you model 1 kilometer by 1 kilometer huge box building without intention, this kind of light shows nothing, okay? It's up to the scale. If you are modeling very tiny object and this light, same number, but totally different brightness because of its scale, okay? You have to follow human scale when you are designing your object in 3D Max. And actually, last week, I told you this is another very important thing. Emit light from shape, okay? Point, line, cylinder, sphere, and so on. Default is usually point. That is why that light is not that good. We're going to take a look at some examples, okay? Sometimes surface is flipped. In other words, if you design a box and if you install a camera inside of that box, if you install light, even if there is light, nothing visible because surface is flipped. In that case, you have to flip the surface. I'm going to tell you using examples in lab exercise hours. Anyway, this is the user interface of mental light. We experienced sky portal and target and free light. Very simple, but if you click free light, you may find out very complicated interface, but I simply put an emphasis on those major important things. First one, light properties on and off, and its intensity and its shape, emit light from shape, okay? Let's take a look at the difference between the shape of light. Okay, there are 3 lights and very simplified building interior. Take a look at shadow, okay? The shadow shape. Those are point light. That is why you can see this kind of sharp edged shadow. Simply think about real environment. If there is very tiny point and there is light, your shadow is going to be very sharpened, okay? But if you change, okay, take a look at the difference before and after. Simply because changing the shape of that light from point to sphere, okay? Sphere light. Take a look at shadow casting and compare before and after. Very smooth shaded because of the shape of that light, okay? That's one way of controlling that style of light. Take a look at this one. This is emit from lines. There are 3 lines, okay? That's why there is another shape of that light. But shadow casting looks very sharp. This one, okay? Emit light from line. This is not the shape. This is the icon of that lighting object, okay? This is the shape. What if you change the lighting into cylinder? In that case, the same smoothed shadow casting you can find out. Here it is, okay? Different shape, different shadow casting, and different environment, different look. That's my point here, okay? And next one is something about camera. Actually, we experienced something about camera by using 3D Max camera or some view control in SketchUp or some different software. But handling DSLR camera is almost same to the camera thing in 3D Max, okay? If you know something about camera, DSLR camera, and then you can sophisticated control by using 3D Max camera. It's all about lens and all about lights, okay? The first thing you have to know is focal distance, the numbers, stock lens focal distance numbers. 15 millimeter, usually we say it's wide lens, and 200 millimeter, that's telescope lens, okay? You can see very far from here, but you can make it bigger using this kind of telescope. But this is wide lens. This is very effective for designers, architects, interior architects, okay? Because by using this lens, we can take entire scene of that room by one single shot. Anyway, this is focal distance. Actually, it's not that hard to comprehend. You have to understand this mechanism, and then you can figure out which focal distance numbers you need for generating your scene. Or you can apply this technique to your DSLR camera, okay? Totally same. If you buy a DSLR camera, default bundle, so-called bundle lens has 18 through 55 millimeter, which means you can dial that lens and change focal distance numbers from 18 through 55. That's default bundle lens, okay? But if you buy 50 millimeter or 80 millimeter, usually good at portrait, okay? Especially good for girlfriend face, out-focused background, very nicely taking pictures by this type of lens, okay? Anyway, this is focal distance. If we have some bigger numbers in focal distance, your scene gonna be changed in terms of its eyesight, wide telescope or wide. Those two different lenses can be varied by this different focal distance, okay? So just simply draw this kind of image when you are choosing some different stock lenses. There is another term, field of view. When you control field of view in SketchUp, you can put everything in your single scene or just zooming in very specific object. So we can control this field of view angle. There is field of view icon. You can control this field of view, okay? So simply we can differentiate those two different types of lenses, wide and telescope. Exactly same to 3D Max mechanism and your physical lens when you are taking pictures using your DSLR camera, okay? So very good for viewing all and looking very professional. I mean, architecturally professional. But cons, a little bit distorted or exaggerated. Very long lag if you take picture low angle using that wide lens. Something changed compared to real. But telescope, zooming in and you can see in detail, but very narrow view, that's the cons. So simple example, 200 millimeter telescope lens you can take this kind of scene. 85 millimeter, 50, 35, 24, 15. This is ultra wide lens. So what is good for interior architects? What is good for interior design? Of course, this kind of wide, especially ultra wide lens. So you need to buy that kind of wide lens when you are buying DSLR camera, okay? So that you can put every scene, every feature in your room by one single shot, okay? But if you want to take some birds on the sky, you need telescope lens. If you want to render flying object on the sky, you have to use that kind of telescope lens in 3D Max. But if you want to render a building or inside of the building, wide lens, okay? Exactly same to real world mechanism. Another one, I would like to show you some visual effect things when you are using this kind of camera. Actually, I told you before when you were freshman, whenever you draw some images or whenever you create some visualization, rendering, this vertical line is supposed to be orthogonal. In other words, 90 degrees to your horizontal line, okay? If this angle is angled or distorted, that picture looks not that professional. Every single professional picture has this kind of orthogonal lines. That's my point, okay? That makes your final render scene looking professional. That's my point. Even if you have some this kind of exaggerated or perspective lines, at least this line must be orthogonal, 90 degree, perpendicular against your horizontal line, okay? That's my point. Actually, I showed you this one a year ago, but at the final project, only few of you follow this rule, very simple rule. But someone followed that rule, their final images looking much professional and much better than others, simply by following this rule, okay? Just buy a design magazine and see the pictures. More than 99% pictures are following this rule. Very simple rule, but it's not easy to follow that rule by some novice students. But you should understand this simple mechanism. Examples: interior scene using wide lens, especially ultra wide lens. 2 perspective points, and the space is looking very wide and very deep and something exaggerated, but all vertical lines are looking orthogonal and looking professional, and you can feel the spatial depths of this actual space. Another wide lens. This cloud actually was on just over my head, but you can take that picture. It's not fisheye, but close to fisheye, okay? Another example, wide lens and telescope lens. Totally different effect, okay? Okay, the last thing about camera we need to know is depth of field. Depth of field, simply say out-focused, okay? Out-focused or in-focused, sometimes someone says. But out-focused picture, because of this focus zone, okay? If the focus zone is very large, we say it's very deep depths. But this one, very shallow depths. Only focus area is here, but most of you gonna be within focus. That's 2 different type of depths. But you can, anyway, you can control that mechanism by using 3D Max interface, multi-pass, okay, multi-pass effect. By using this one, you can generate some additional features, but I would like to introduce you, there is this kind of aspect, but it's not mandatory. You don't need to use that because we have much better application, faster and efficient one, Photoshop, okay? But sometimes we need to make this kind of scene by using 3D Max. Let me show you an example. This is real picture by taken by my DSLR camera. This scene has focus zone is this area. That is why this area on focus, but all others out focused. So this picture is looking professional and looking visually looking good because of the out focused. But when you change its steps to this area, we can find out something out focused on that different geometry. Same technique when you are rendering in 3D Max. Take a look at this one. Default is very deep depths. That is why we can generate this kind of render scene. But if you control only this post has the within the focus, all others gonna be out focused. The reason for this one, very looking coarse, I simply put just default numbers in terms of its render technique. Anyway, this one takes really long time, but if you make that very fine grained and then more time you need. Anyway, time consuming, but you can make that visual effect, okay? Take a look at that one. Focus zone, different, the same effect, multi-pass. But let me show you this one. This one has the focus zone is here. The third one, others out focused, but this one done by Photoshop in just 30 seconds. But for this one, by using 3D Max, we need 20, 30 minutes just for rendering, okay? So it's up to your decision, but I recommend to use Photoshop. But anyway, if this is very complicated geometry, in that case, we cannot do the same thing by using Photoshop. We have to use 3D Max. Anyway, that's my examples and mechanism. Take a look at this one. Same multi-pass example. Probably next week, when we are dealing with some complicated rendering options, we're gonna deal with this one, okay, next week. 3D geometric modeling review from the last week, okay? Today, we experienced some control against vertices, edges, especially polygons. By using this one, editable poly, okay? We can control vertex, edge, and polygon. When you are controlling polygons, that is totally different from controlling vertices, okay? Simply imagine you are drag and drop vertices, edges, or polygons. Its geometric shape totally differently updated, okay? That's what you experienced probably by handling some spoon object. That is why spoon object has very curved shape and looking very simple, but something very complicated. Very good example for learning how to control those sub-geometry objects. So this interface, very important and fundamental, and another complicated way of getting your own geometry, okay? But actually there are a lot more modifiers and methods and sometimes even better ways. I'm gonna tell you later in lab exercise hours, but today, as a novice 3D Max users, we have to use this kind of very fundamental and tedious, laborious, time-consuming geometric editing. That's what you need to know at first stage. Anyway, making primitives, something like those items, and put amount of modifying tools or some editing tools, especially by using editable poly. And then you can create this kind of things I introduced you last week. But everything looking very different, but it's in terms of its basics, almost same. Getting 2D first and extrude them or sweep them, that's fundamental way of creating 3D object. Lathing, what you have learned today, is one type of geometric edit method. And of course, sweeping is different type of extrude. And sweeping is one of the important things in 3D Max-based geometric modeling. Some others, especially Boolean operation, is another important thing. Making some unimagined, very creative objects can be created by this kind of operation. Okay? Some imaginary objects can be created by using something different. But our major objects are buildings. Thankfully, they are all orthogonal against our ground. Everything orthogonal, 90 degrees from the ground. So we can reuse CAD files, 2D drawings, extrude walls, and make holes on wall object, and then we can take advantages of some predefined geometry, such as windows, doors, and so on, in 3D Max interface. And you can easily and quickly generate your own building geometry. That's what I showed you last week. And we're going to deal with this one later, not now. We're going to deal with some fundamental geometry edit first, and then move on. So that's what I showed you last week. From primitive, from 2D drawing, from predefined 3D objects, and some recursive edits. That's what we can get your own 3D geometry. But again, I like to say making geometry is really time-consuming, tedious, very recursive activities. We don't have time in our 4-hour class spending a lot of time for modifying and creating your own geometry, your own design. But we don't have homeworks, lab exercises. That's why I distribute some reference tutorial video files, and some reference website or books, and so on. Train by yourself, especially for learning this kind of geometric editing, geometric modeling. Anyway, it's time consuming, okay? I don't want to spend our lecture time for doing that kind of training, that kind of time consuming training event. Anyway, some examples by using 3D Max, revolving, for making this kind of shape, looking very different, looking very difficult to make this kind of geometry, but actually very easy if you understand how 3D geometry can be revolved or extruded by this kind of 2D geometry, okay? Simply draw 2D and modify its 2D and revolve it. After revolving this shape, go back to this stage. If you control the thickness by controlling these points, and then your final object's gonna be real-time updated, okay? Exactly same to editable poly, editable mesh, editable spline, and so on. That's the mechanism of making 3D. If you understand 3D geometric editing mechanism, probably you may easily understand this kind of process. That's my point, okay? That kind of vase, 2 boxes, bigger one, smaller one, and bigger one minus small one. And then you can generate that kind of geometry easily, just by using 2 primitive, okay? So editing geometry really complicated and time consuming, but fundamental is here. Editing vertex, editing edge, editing polygon. That's it, okay? Until do again and again until what you want to get from that kind of recursive and time consuming edits, okay? But thankfully in 3D Max, this is 3D Max interface named modifier. There are a bunch of modifiers, amount of modifiers. Actually, we don't need to know all of them, but there are very important modifiers. We would like to learn what are there. For example, turbo smooth. If you apply turbo smooth against your merely made spoon, that spoon gonna be really looking very curved and realistic. Simply apply turbo smooth. By its literal meaning, making smooth. By turbo, you know what's turbo, okay? Dramatically change your shape in smoother way. Anyway, some modifiers, edit poly, norms, subdivision, another type of smooth, FFD, freeform deformation. We're gonna deal with this one probably after next week. You can control some external point and make very complicated shape, mesh smooth, turbo smooth, and so on. Probably next after next week. Again, I like to show you this one. Learning 3D Max design and its mechanism behind the technology, not just interface of 3D Max. You don't need to know interface. You have to understand its mechanism behind the technology. How to create 3D geometry from 2D. What kind of modifiers exist currently, such as revolving, lathe, or some extrusion, sweeping, and so on. The terminology is different, software by software, but mechanism totally same. So what you need to know is this kind of fundamental process, what you can do. Modeling, rendering, animation. From next week, we're gonna deal with modeling and rendering. Half of your lab exercise is gonna be some geometric modeling, especially architectural objects. Half of them, some advanced features on rendering things, so that you can get your design visualization effectively and easily. And also animation thing in probably at the end of this semester. Again, this diagram is very important in terms of your use scenario of 3D Max, okay? Defining UOD and very time-consuming geometric modeling and rendering, test render, and go back, update your model, update your material, camera, lights, environment, and so on. And some 2D-based retouching, especially using Photoshop, until the image, what you want, created, okay? So I list up 3D Max use scenario again. Before doing something, you have to define your world first, defining universe of this course first. That's what I put always emphasis on. And 3D modeling is very hard and time consuming, tedious. So reuse predefined one, download your geometry and try to edit. Sometimes it's easier, create by nothing, create from nothing, from scratch, rather than import your SketchUp file, okay? sometimes create your own object only by using 3D Max is easier and faster. And also rendering, something complicated, but I told you, take maximum advantages of mental ray and Autodesk material and your own pictures rather than using some complicated features. But at the end, you have to control very sophisticated options in renderer. We're going to deal with that in our lab exercise hours. And some Photoshop skill, always important. Also, use hotkeys. The single page, the most important hotkeys listed up here, okay? So let's get back to the lab exercise, okay? Finish up the lecture and get back to the lab exercise, okay?